Hello, my name is Ian Burke, and I decided to uncover all the facts and history of tryptophan for my molecule project. My initial reasons for picking this molecule were A, it was one of the few options that I had left to choose from, and B, I heard of it before with the myth of eating turkey and becoming drowsy, which is something I will address later in this video. Now, I wasn't expecting too much from this learning experience, to be completely honest. However, I was completely wrong about that. Tryptophan, as seen in the structural diagram at the bottom of the page, truly has changed the game in the sense that its discovery was the key of sorts for the introduction of vitamins and other essential chemicals in the healthy dietary range of humans. In a chronological sense of this video, I will first give a brief history on the discovery of the compound, then delve into the physical and chemical properties, highlighting interesting facts, and finally end on why I, and many others, believe tryptophan is important. So without further ado, let us journey into the facts and history of tryptophan. A man by the name of Frederick Hopkins, pictured below, discovered the molecule tryptophan back in the early 1920s. Frederick Hopkins is known as the father of British biochemistry for his work in the field. He was even rewarded with the Nobel Prize in 1929, along with other prestigious awards. However, the tryptophan research came way before this, while he was still a lecturer for a university. The story begins with him in the lab, where he noticed two solutions did not mix the way that he had expected them to. Now, this puzzle led him to synthesize tryptophan eventually, and this molecule ended up having a greater effect on his career, and societal health for that matter, than expected. However, I will speak on this more later in the video, but for now, let's take a look at the physical and chemical properties of tryptophan. Although there are a multitude of physical and chemical properties that could be listed, the common values of both are presented on this slide. Tryptophan has a melting point of 291 degrees Celsius, is a solid at room temperature, and is soluble in water. The molecular formula is C11H12N2O2, and it is an essential amino acid. The actual structure of the molecule contains an indole group, a carboxylic acid group, a carbon backbone, and an amine group. In fact, the entire structure is nonpolar, and this is because of the lack of OH atoms that are connected to the amine group, or the R group, thus making it impossible to have polarity. Now, there are a couple of interesting facts presented here on this slide. Serotonin, a chemical in the brain that can cause drowsiness, is actually derived from tryptophan. Now, this is the key point that helps to support the real reason as to why we become drowsy after eating so much turkey. Contrary to popular belief, the tryptophan levels in turkey aren't any larger than those of other meats. The fact about this whole process is that the insulin released into the body clears all of the other molecules except for tryptophan out of the blood after the ingestion of copious amounts of carbohydrates, for instance. Now, a higher concentration of tryptophan in the blood is the outcome of this process, which leads to a higher concentration of serotonin, and thus a higher drowsiness. Tryptophan can be effective in small doses, and is a molecule of extreme importance to the human diet, which I will talk about in the next slide. Speaking further on the importance of tryptophan, which I have mentioned a couple times in this video, hopefully you've noticed, the discovery of it led to bigger and better revelations in the field of healthy eating. For instance, Hopkins' next big research project after this essential amino acid discovery involved the development of vitamins, another essential part of a healthy lifestyle, something we need to have in order to survive. This keen interest helped to unlock the secrets of the body and further prove the theory that healthier eating will help lead to a longer and healthier lifestyle. Without tryptophan, and Hawkins' work, of course, humans wouldn't be here today. Plants also would be void and not exist because of this molecule aid in fighting off insects, for instance. Frederick Hawkins was the father of British biochemistry. That's known. And he's also, more importantly, the father of vitamins and tryptophan. And for my last slide, essentially is a references slide. These are all the different sources that I use to be able to provide me with the information to create this PowerPoint and bring it to you. And I thank you for listening once again.